Alright, so we want to solve this equation. The equation is sine squared of theta is equal to 2 cosine of theta plus 2. Now note here, we only want to find the solutions from 0 to 2 pi. Okay? And the first thing we notice here is that these are different trig functions, right? This is in terms of sine, this is in terms of cosine, and that's no good. Right? So the main thing to remember here is we have to get everything in terms of the same trig function. Okay? And remember, cosine, right? Cosine of theta and cosine squared of theta, these are actually the same thing, right? It's the same variable except one is just a square root of the other. And similarly, sine of theta and sine squared of theta are also the same variable, right? It's just one is the square of the other. Okay, but these are different, right? Sine and cosine. So we have to use an identity. And we know that there is an identity for sine squared, right? That can help us to convert that into cosine squared. Right? So we know that sine squared theta plus cosine squared theta is equal to 1. So we can use this identity that sine squared is equal to 1 minus cosine squared. Okay? So once we replace that, right, we get 1 minus cosine squared of theta is equal to 2 cosine of theta plus 2. And this is good, right? Because we have everything in terms of the same variable. So let's get everything to one side and set the whole thing equal to 0. Okay, so I'll add the cosine squared over, I'll subtract the 1 over. Okay, so I'll subtract the 1, I'll add the cosine squared to both sides. Just the cosine squared, right? Now notice what happens here, right? We get the 0 on one side, which we want, right? Anytime we solve equations, we want a 0. But notice what happens on the other side, right? We get cosine squared theta plus 2 cosine of theta plus 1. Okay. And this is a quadratic type equation, right? Now, obviously it's cosine squared and cosine, but let me ask you this question, right? If I ask you to solve this, right? Let's say x squared plus 2x plus 1 is equal to 0. Right? How would we solve this? And this is a factorable, right? This is a perfect square trinomial that looks something like this. So along the same lines, we should be able to factor this, but instead of putting x's, right, we're going to put cosines in its place. So we get 0 is equal to cosine of theta plus 1 squared. And now we should be able to solve this for cosine, right? So if we take the square root of both sides, you notice that the 0 just goes away. The 0 doesn't go away, but the square goes away. So 0 is equal to cosine of theta plus 1. Okay. So from here, we can set this equal to negative 1. I'll subtract the 1 over. So then, all right, where does cosine equal negative 1? Right, and you've got the unit circle. You should be able to tell, right? The answer here should just be negative pi, right? So that is going to be the answer here. This is the solution. There's only one answer here, right? So when theta is equal to negative pi, sine squared of theta is equal to 2 cosine of theta plus 2.